Got to change it over on the YouTube side of things. Cool. Maybe pull up NSF. That's the right mission, right? Have they not gone live yet? Huh. Yeah, the cast should be going live like now. Oh, there we go.
Tanks are pressing for strong battery recharge.
All right, we got Starlink 6-62 going out of Slick 40, Cape Canaveral Space Force Station down in Florida. First stage flying tonight is booster number 1080. It's its 8th flight off of a 34-day turnaround. It's carrying a second stage with 23 Starlink V2 minis on top. And those look like reused fairings, but I'm not 100% sure. I'm going to guess more often than not that it probably is. It seems to be a pretty clear night out in Florida, just a little bit windy. Let me check the wind corridor. Hold on. This should be a southeast trajectory. So it should fly down near the Bahamas. Let me take a look here. Set the altitude. Wind's around 8 knots right now. At flight level 300, we got 31 knots coming from the northwest. 44 knots northwest at 45,000 feet. 14 knots coming from the north. Yep. Yep, conditions are good. Yeah, wind conditions are good. There's no vertical wind shear. Wind's all going in the same direction for the most part. Good, good. I think this is something, SpaceX is well over 50 missions here for the year. We're not even halfway through, and SpaceX has done 53 missions. They're targeting, supposedly, they're targeting 100 plus. They hit 96 last year. Yeah, there's some lighting on the fixed service structure. This thing was recently added. SpaceX has the ability to launch crew from 2 different pads now. They could launch crew from Slick 40 or 39A. Strongback is retracted into the 89-degree position. You go 150 to 200 for launches this year. They're going to have to step it up during the summer, man. Do you think they can do 100 plus? Easily. They'll easily hit 100. I would say, Tech, mark my words, I'll say 117 launches this year by December 31st. 117. Watch.
Stage 2 lock float complete.
Yeah. They've had, there's just some things you can't take into account, like weather and stuff, like payloads, the supply chains, etc., you know, but yeah, we'll see what happens. Right now, Falcon 9's going through a ground gas closeout where they get all the liquid oxygen and RP1, the 2 propellants for this vehicle, out of the transporter erector, that truss structure on the left. You want to get the fuel out of that so that doesn't catch on fire when you go to launch, because, you know, you need it to launch another one later. That's the quick version. Falcon 9 should be going into startup here in about 10 seconds. This is a throwback short line. Slick 40 is throwback. Yep. That truss structure
Falcon 9 is in startup.
that's bent this way will shoot back when the rocket lifts off. Falcon 9 is in startup. Yeah, you don't want to light your launch pad on fire. That's pretty bad for it. LD reports go for launch. Nope. Yeah, but they have not launched people
T-minus 30 seconds.
from 40. Vandenberg's the old one, yes. T-minus 20 seconds. Sound suppressor should be turning on in the next 10 seconds.
T-minus 15 seconds.
Sound suppression system is on. There's spraying water all over the pad right there. 5 seconds.
5, 4, 3, 2,
Ignition.
1. Lift off.
Okay, Starlink 6-62 in the air, launching 23 Starlink V2 minis on a southeast trajectory
Vehicle is
out of the Cape Canaveral Space Force Station. Everything looks good there. Vehicle is moving. Let's see. Notice how it's turning. You can figure out its trajectory. Yeah, that's southeast Starlink trajectory. The reason why SpaceX back in the day, I mean back in the day like 2 or 3 years ago, they used to launch northeast for Starlink satellites. Starlink satellites are in a tilted orbit, so out of Cape Canaveral you can either go northeast or southeast. I believe they went with the southeast trajectory. They favor it more nowadays. The reason why they favor it more is because calmer waters for drone ship recovery.
Falcon 9 is supersonic.
Supersonic power and telemetry call was good. 70 seconds in. Should be hearing max Q here.
Max Q.
You like when they do the slow roll around. Think like that's called a roll program. The roll program establishes the flight azimuth for inclination insertion. If that made no sense, the vehicle's turning to an azimuth relative to a compass heading, that's going to get it in the right tilted orbit around Earth. You look like a youngster. Yeah, I know, man. All right. MVAC chill has started here. The second stage engine is now being primed and thermally conditioned for flight. I mean, it is flying right now, but it's going to be powering the flight here in another 30 seconds. 23 on the docket for today, Charles. Say that 5 times fast. Yeah, right. I swear. Philadelphia, I swear. I swear these words are English, okay? I swear. I know people just be like, yeah, I don't know what that meant. That's why I try to keep it simple. How many in total are up there? Over 6,000, dude. I know, Sup. It's pretty sweet. Engine cutoff.
Stage separation confirmed.
Good second stage separation. Beautiful shot of Florida back there. Upper stage ignition. We have second stage engine start 1. SES 1. Engine's glowing. First stage will now coast here on basically I'm not going to say it's a ballistic arc, but
Vehicles are following nominal trajectories.
But it's basically a ballistic arc till it gets to entry interface where it does its entry burn, the supersonic retropropulsion.
Fairing separation confirmed.
In preparation for landing. There go the fairings. The fairings are the aerodynamic shell that's protecting the satellites. The satellites are stacked like a deck of cards on top of the second stage here. Now, there you go again. Oh, damn. Sorry about that. This thing is now pushing the skyscraper of satellites. They just stack them on top of each other because they're thin. Stack them on top of each other. They have a shell in front of it because satellites are not aerodynamic. Yeah. Fun fact. The engine isn't glowing there just, you know, because it looks cool. I mean, it does look cool, right? SpaceX uses a special metal alloy right there on their second stage engine, and the glowing is actually that's thermal radiation. The glowing is what's keeping the engine cool. That's why SpaceX has so many cameras on this thing, because that if the glow is not uniform, we got a big problem. But doesn't seem to be any of that today. Everything looks nice and uniform there. It's using thermal radiation there to keep that nozzle cool. I always forget the metal that they use. Niobium. That's it. That's it. Yeah, I think like. Yep. That's hot, indeed.
Both vehicles continue to follow nominal trajectories.
Okay, everything's looking good here. Okay, second stage crossing 12,000 kilometers an hour at 146 kilometers. First stage, 7,300 kilometers an hour below the Kármán line at 93. What do you think about moon landing hoax theories? I don't, Atomic. I don't, man. Honestly, it'd be harder to fake than just to freaking go there. You know what I'm saying? I don't pay it no mind. With that being said, if people want to think that, I don't get all bent out of shape about it either. You know what I mean? Either. Oh, God. Sorry, my native tongue came out for a second. Yeah, I know, Eric. It's gonna suck. Here's the best part. Supersonic retro propulsion. All right, pay attention. You got some big words coming at you here, okay? So, the first stage is going to experience re-entry unless it slows down. All right? Re-entry heating does happen. The first stage is going fast enough to experience it, but it does this entry burn. The entry burn here slows down Falcon 9, but it also provides a thermal barrier for the first stage. It's called supersonic retro propulsion. I told you big words were coming. You were warned. So what that actually does, not only does it slow it down, that first stage pushes the re-entry heating away. See the re-entry heating that's happening on the grid fins? That's an inconsequential amount. See it up there? It's scorching those titanium grid fins, but the titanium doesn't care. It's fine. Right? But for the peak part of heating, they can actually use the engine to push the accumulated re-entry heating. Plasma, they can push it away. And that's what it does, that's my favorite part. It's the best part. Yeah, look, see? Re-entry being live streamed to your freaking computer or mobile device. Now, the first stage is using atmospheric density to slow down. As you get closer to the ground, the pressure goes up. When the pressure goes up, there's more air in the way. It slows the stage down. Second stage over here is about to cross 20,000 kilometers an hour. 143? It's going down. Uh-oh. I don't think that's... 142. That number shouldn't be going down.
Stage 1 landing burn.
Oh, okay. First stage is now going to land on a converted barge here.
Stage 2, terminal guidance.
Shortfall of Gravitas landing leg deploy is the name of the ship. Made it look easy.
Landing confirmed.
I don't remember in recent memory the apogee going, or the altitude going down. That means it's past apogee. 137. I mean, it's circularized. There it is. See the blue line? Stand by for the call for nominal orbit insertion. And they cut the cast. Damn it. They did burn radial inhibit, yeah. Or they set it on a different trajectory. Usually you don't see the altitude go down for a rocket launch. That's unless it's a very specific trajectory. Yeah, going down is generally what you don't want to do. But for different types of lower energy orbital insertions, there's those big words. This is happening again. For a certain type of orbit, you might want to do that. It really depends on where you're going. So not as fun. Yep. You got the same thing in Fallout, JDG? That's cool, man. All right. Double secret, super secret squirrel insertion. Yeah. Double insertion from both sides of the rocket. I'm 35. Did you know that? Making jokes like that? Yep. Okay. Forehand's like, double? Wait, what? Get out of here. All right. I hope you guys enjoyed that Starlink launch. That was Starlink Group 6.62. Old and bald. Yep. All right. That's going to do it for me. I hope you guys enjoyed it. Tomorrow, I don't know. Kerbal, Fallout, stuff like that. We should do some space news. There's a lot of space news to talk about. I think we'll do Fallout into space news tomorrow. That's probably what we're going to end up doing. So, like a fine wine. Thank you. Why do you think that SpaceX flying humans to orbit wasn't live because of technical difficulties when the moon was live? Technology has improved atomic in the last 50 years, dude. And we did get live streams of the landing. It just wasn't called streaming. It was called television. The Apollo lunar excursion module was capable of high gain TV signal, but here's the thing. So it could broadcast television, right? But here's the thing. You needed the Apollo service module, the other thing that was floating around in orbit. You needed that as a relay, or else the thing couldn't transmit all the way to Earth. So that's why you didn't get signal all the time. If the command module isn't in line of sight of the lunar excursion module, the LEM, when it's down on the ground, they're not able to relay the signal. There's a movie about this called The Dish, if you're interested. It's The Dish. It's a great film. Okay, Etel's playing Star Citizen. I don't know if I should keep rating him though, because I might watch and be like, ooh, this game, but I don't want to. I don't want to. All right. Anyway, guys, go see what my buddy Etel's up to. He's looking at some pretty cool looking ship in a hangar. And I will see you guys all tomorrow. You should debug those theories sometimes. I get all the questions in the world, Atomic. If you want to come back and pick my brain about it, I'm here 5 days a week. 10-hour streams, 5 days a week, Monday through Friday. I'm usually here. And come June 1st, guys, probably going to have to stream that Saturday as well. But we'll talk about that tomorrow for Space News. Thank you very much for watching. Go raid Etel. I'll talk to you guys all tomorrow. Thank you.